I should say this is joint work with the Wáng. So like François said, this is about somebody knows. So as most of you know, different notions of group knowledge and belief have been extensively studied. So the most common ones are everybody knows. Everybody in the group G knows that phi is true, which is stronger than distributed knowledge, which is the total knowledge in the group, or what follows from the total knowledge in the group, but is stronger, but it's weaker than, it's stronger than distributed knowledge, but weaker than common knowledge, which also requires that everybody knows, and so on. And usually, so like I said, these notions of group knowledge, they have been studied extensively. Usually they are formalized using modalities of this form you see on the slide. So CG, DG, EG, where G is a group of agents. So in this work, we study a closely related and very natural notion of group knowledge that surprisingly haven't been studied a lot, namely somebody knows. So SG phi means that somebody in group G knows that phi is true. Now, this is in between E and D. So it's weaker than E, but stronger, weaker than everybody knows, but stronger than distributed knowledge. And the question you might have on your mind right now is why? Why? So we are interested in studying the properties of the somebody knows operator, but why? I mean, just like everybody knows, somebody knows can be completely characterized using individual knowledge, like you see on the slide, using disjunction. So this is a complete characterization of the properties of the somebody knows operator. So why are we interested in studying those? Well, so even if that is true, this characterization don't give us doesn't shed very much light on interesting properties of that modality, right? So properties like, does it satisfy the positive introspection axiom? Does it distribute over conjunction? Properties like that are commonly studied and of interest in epistemic logic and in modal logic in general. So in addition to being interested in studying the basic properties of these operators, there's another motivation as well. So even though adding these modalities, these operators, somebody knows operators, to the epistemic logic language doesn't make it more expressive, it does make it exponentially more succinct. So if you have a formula with a nested somebody knows operator, like at the bottom of the slide here, it kind of, if you write that out using just individual knowledge operators, it kind of exponentially explodes. The formula increases exponentially in the number of agents. So you could argue that it's unrealistic in practice to reason about somebody knows from first principles. So an example of a formula like that would be at least one of the attackers know that somebody in the group knows the password, something like that. Okay, so in order to understand, get an understanding of the basic properties of the somebody knows operator, we isolate it in a minimal language without other epistemic operators and just with a single modality of somebody knows for the grand coalition of all the agents. So just a single S operator in the language. And like I said, we do this in order to understand just the most fundamental, the basic properties of this modality. So the models we use to interpret this language is just standard cryptic models for over a set of agents. So the cryptic models are parameterized by a set of agents, although the language is not. So there's a binary relation for each agent in this set. And S phi is now true in a model if there is at least one agent and all the states that agent considers possible in the state S, that formula phi is true. So now what about the properties of this? Well, let's look at the S5 case first. So in that case, if we assume that the individual knowledge relations are equivalence relations, then it turns out that the S modality satisfies the positive introspection axiom and the truth axiom, but not the negative introspection axiom. So it might look like this is a KT4, which is the same as S4 modality. But hang on a second, because let's look at more general properties. So it turns out that we have the necessitation rule for the S operator. We also have the replacement of equivalence rule, like in standard model logic. We have the monotonicity rule. It distributes over conjunction in one direction, but not in the other direction. And that means that this is not a normal modality. The S modality, the somebody knows modality, is not normal. It also follows then that it doesn't have a relational semantics, right? Like everybody knows. It's very, very similar to everybody knows, right? We just changed the conjunction to a disjunction, and everybody knows has a relational semantics, takes the union of the accessibility relations, but turns out there is no relational semantics for somebody knows. Now, okay, next question. Are there any other interesting validities, or are these the only validities or rules or potential rules and axioms? Actually, it turns out that there are, and here is one. And it says basically that if there are only n agents in the system, and somebody knows phi1 and somebody knows phi n plus 1, then there must be someone who knows the conjunction of these of two of these formulas, right? Because n is the number of agents, right? And this is if you look at this is a weak form. We don't have full conjunctive closure. That's a C axiom. We lack that. This is a form of weak conjunctive closure. So we have this. Note, by the way, that this means that the logic is different from different numbers of agents, different validities for different numbers of agents, which is interesting. Okay, so by the way, so it's not a normal model logic, but if you look at these three first axioms and rules, they actually are they are known as a subnormal modal logic, the system EMN, and in particular we have the replacement of equivalence rule, which means that we have all the principles of the weakest modal logic with neighborhood semantics. So there is a chance that we have a neighborhood semantics for this logic, and that indeed is the case. In the paper, and I don't have time to go into details here, but in the paper we define a class of neighborhood models that interpret this S modality in the standard way, and that is equivalent to interpreting the modality on the class of all Kripke models in the non-standard way. Yeah. And so going back to these properties here, actually, it turns out that these are all, with this additional BN axiom, these are all the properties. So this is a complete set of properties for characterizing this. So what you see on the slide here is basically the same axioms I had on the previous slide. I just replaced necessitation with this N axiom, which is equivalent, and this is sound and complete with respect to all Kripke models, and also with respect to the neighborhood semantics that I mentioned, and actually we used the neighborhood semantics to prove this completeness result. We call this, so the system is called EMNBN. So that's the standard system EMN extended with this weak conjunctive closure axiom BN. We also show that the satisfiability problem is p-space complete. Okay, I see I have a few more minutes, great. So then I can talk about this. So I want to talk about, for the last few minutes, about the relevance of this logic in a more broader context. Yeah. So now I use just a modal box instead of the S modality, because I want to talk about this in a more broad, more general modal logic context. So this is the axiom BN that I mentioned. This is not the first time weak conjunctive closure axioms have been studied in literature. Here's a variant, KN, and it's simply obtained by just moving that box outside the scope of the disjunction. Yeah, and it's easy to see that this is weaker. So K, at least in the system EMN BN, we can prove the formula KN, so it's weaker. Yeah. And this is relevant because of the following. So now I take a short detour to the logic of so-called local reasoning. And this was developed by Vardy, and also later by, actually it's in the knowledge, reasoning about knowledge book. It was developed for the logical omniscience problem. So local reasoning models, there is a single agent, but the agent can have several frames of mind. And now, if you restrict the number of frames of mind the agent can have to n, we get exactly the same logic as the logic of somebody knows. So there is a connection there. And actually, this kind of n-bounded local reasoning has been studied in a paper by Allen from 2005, where he claims that actually, if you take EMN and add this KN axiom, then the resulting system EMKN is sound and complete with respect to these unbounded local reasoning models. Turn out we discovered that is actually not true, that is a mistake. We show that actually it is local reasoning models, unbounded local reasoning models are actually completely axiomatized by EM and BN. And we show that is strictly EMBN is strictly stronger than EMKN. So to sum up, as you see at the bottom of the slide here, we have the system EMBN is strictly in between EMNKN and K. So it is a stronger conjunctive closure logic than previously known weak conjunctive closure logics, but it's not full conjunctive closure. And I see I'm on time. Good. I have. Let me just mention some conclusions. So we isolated this somebody knows modality. It's non-normal. We developed a neighborhood semantics for it, which is equivalent, and it's completely characterized by this logic EMBN, which is, as far as we know, a weak conjunctive closure logic that hasn't been studied before. And we corrected this result in Allen about local reasoning. We don't have a completeness result for the S5 case, but we conjecture that if we add the T and the 4 axiom to this logic, we get a complete logic, but we don't have that result. And I have time for questions now, so thank you.